The naming of ethers works differently than the naming of other functional groups such as alcohols, because ethers don't have their own unique ending that designates it as an ether, like an alcohol ending in -al, or an alkene ending in -ene. Ethers have no ending. To name an ether, what we do is divide it into two sections, the alkyl group and the alkoxy group. We begin by finding the largest carbon chain, naming that, and then bonding to it the alkoxy group. So if you want to think of naming ethers, think of it more as naming an alkane or some other alkyl group than naming an ether. So to do this, here's an example: carbon, oxygen, carbon, carbon, an ether. We look for the largest carbon chain here. Name that, take that to be the base. So this is ethane. And then bond it to it an alkoxy group, methoxy. So methoxy, ethane. Also important to note is with ethers, people tend to use the common names a lot more than they do with other functional groups. And this is because they're really, really easy. Actually, it's for a couple of reasons. So this is how the common names work. Oh no, I did yellow. You divide it right down the middle of where the oxygen is. Name the group to the left of it, methyl, and to the right of it, ethyl, ethyl methyl ether. Really simple, and the good thing about it is it lets you know exactly where that oxygen is, where if you get some systematic name like this, you kind of have to figure out. This one is really simple, methoxyethane. That's a really simple one, but you got some other ones that are a little bit longer, and you kind of got to pause to think for a second, okay, where exactly is that oxygen? But with this, you know right away. And why do people do that more often with ethers and not with the other ones? Well, I'd say it's because you got to know a couple of properties of ethers first. First is that they're very unreactive. Second, they're good polar solvents at the same time of being not reactive. So often what people will do is use ethers as a solvent in place of water or alcohol, so no reactions take place. So the whole point is it's a very good solvent. It's polar, and it's not reactive. It's very hard to react with something. So people tend to use it in a lot of reactions where a side reaction may take place if someone does it in water or alcohol. But anyways, the whole point of it is that with these ether solvents, they tend to be relatively simple molecules, not very big. And as you get larger and larger, and if it's still an ether, it tends to have, the larger and larger you make that molecule, the less ether properties it has. When someone is using an ether for the sake of it being an ether, they tend to be very small. If you have some big molecule, it lessens the properties of it being an ether. Or if it's on a big biomolecule, then there are all these other reactive groups on there. It's kind of like a spectator almost. It's at least when I see a very big molecule, and there happens to be an oxygen bridge there, I don't really tend to think of it as an ether. Often when people are using ethers for the sake of being ethers, they're being used as solvents, and they're very small and simple. And using this where you divide it down the middle to name it, it's just a really simple way of just let someone know right away where the oxygen is, and anyone can just look at it and just wing that name. Just real simple. So anyways, we'll continue on. The next one, find the alkyl group. So we've got one here, one here. We'll use this one so we don't have to number anything. So methane is the base. Now an alkoxy group, so methoxy, and we have this chlorine here, so chloromethoxymethane. Or, to use the common name, this is a chloromethyl group, this is a methyl, so chloromethyl ether. Two more examples. So the largest carbon chain is the ring. We'll use that as the base, cyclopropane. And the alkoxy group, methoxy, cyclopropane. To use the common name, divide down the middle, cyclopropyl, methyl, cyclopropyl methyl ether. And here's one where if you divide it down the middle, yeah, sure, you could probably come up with a common name for that, but no one's going to really use the common name for that. I mean, you'd have to sit there and think about it. So that's an example where you're just going to use the systematic name. Find the largest ring. 1, 2, 3, 4, 5, 6, so cyclohexane. So 1, 1. These are methyl groups. And then we have the alkoxy group. So here, in this case, it's going to be ethoxy because there are 1, 2 carbons to it. So this will be 1, 1, 2, 4. Hang on. Made a mistake there. Okay, so yeah, let me make sure. 1, 2, 3, 4. Yeah, 4. So this will be 4 ethoxy, 1, 1 dimethyl cyclohexane.